Assalamualaikum. So today we are from Group 8. We would like to present to you about STA 568 Assessment 2 Question 8. Before we go to the question, I would like to introduce myself first. So my name is Muhammad Amin Aiman bin Hamis.
And my name is Idran Hafi bin Muhammad Sherus.
Okay, first we go through the question first. Let S1, S2 until Sn be independent random variable that come from a normal distribution with mean 0 and variance to theta. For the question A, find the distribution of a new random variable yi equal to si square using the moment generating function. Okay, first we write the information first. As follow normal distribution with mean 0 and variance to theta. The PDF for S is 1 over square root 4 theta by exponent negative 1 over 4 theta x square with range S negative infinity to infinity. After that, we use moment generating function technique. MYT equal to expected exponent TYI, then we substitute YI with SI square. Since we don't have the distribution for SI square, so we need to use the integration. Then we integrate negative infinity to infinity exponent tx square times with fx dx. After that, we use the fx that we have right. Then, since there are two exponents, so we merge them with plus the power of exponent. After that, we factorize the negative x square, then we equalize the denominator in the bracket with 4 theta. Then, we will get in the bracket 1 minus 4 theta t over 4 theta. After that, we move the bracket to the denominator. So, we will get integrate negative infinity to infinity 1 over square root 4 theta by exponent negative x square over bracket 4 theta over 1 minus 4 theta t. After that, we factorize 2 from the bracket and we move the denominator in the bracket up to numerator. Then at 1 over square root 4 theta pi, we multiply both the numerator and denominator with square root 1 minus 4 theta t to the power negative 1 to make it like the general form of PDF normal distribution. Then we factor out the constant, then we will get square root 1 minus 4 theta t to the power negative 1 and the integrate negative infinity to infinity 1 over square root 2 theta 1 minus 4 theta t to the power negative 1 2 pi exponent negative x square over 2 theta 1 minus 4 theta t to the power negative 1 is equal to 1. Lastly, we can multiply the power negative 1 with 1 over 2. Then we will get 1 minus 4 theta t to the power of negative 1 over 2. Therefore, y follow gamma with alpha 1 over 2 and theta for theta.
Next, I will explain about question B. The question B asks, use the result in A to show the distribution of W equal to summation of xi square over 2 theta follow a chi-square distribution and hence state the parameter of W. So firstly, we need to find the moment generating function of W, which is expected of e to the power of tw. And then we will replace the power of W, which is summation of xi square over 2 theta from I square to 2 to n minus 1. Then we will separate the 2 theta and become t over 2 theta. So the expansion of summation xi square will be x2 square plus x3 square and plus until x minus 1 n minus 1 square. And from there, we can expand it with t over 2 theta. Therefore, we can change it to a moment generating function. From the result in question A, we already know the MGF of each square normal random variable, that is 1 minus 4 theta, and substitute the t into t over 2 theta and to the power of negative 1 over 2. And next, because there are n minus 2 independent square terms in the sum, we multiply the MGF together. This gives 1 minus 2t to the power of negative 1 over 2 times with n minus 2. Now we compare this result with the standard MGF, of a chi-square distribution, which is 1 minus 2t to the power of negative k over 2, where k is the degree of freedom. And lastly, we can conclude that the random variable w follows a chi-square distribution with n minus 2 degree of freedom.
So next, we go to the question C. Based on B, construct a 1 minus alpha 100% confidence interval for theta. Okay, first, we take the formula of the estimation of variance. So we get P bracket chi-square 1 minus alpha over 2 n minus 2 less than or equal W less than or equal chi-square alpha over 2 n minus 2 equal 1 minus alpha. The degree of freedom chi-square is n minus 2 because we get it on the question B. Then we substitute W with summation I equal to 2 until n minus 1 SI square over 2 theta. Since we only need theta, we need to divide it with summation I equal to 2 until n minus 1 SI square. Then we also need to divide it to the both sides. Then we get 1 over 2 theta. Then we need to invert the fraction, so 2 theta become the numerator. Since we invert the fraction, both sides also need to invert and interchange the upper and lower bounds. So we get P bracket summation I equal to 2 n minus 1 SI square over chi-square alpha over 2 n minus 2 less than or equal to theta less than or equal summation 1 equal to 2 n minus 1 SI square over chi-square 1 minus alpha over 2 n minus 2 equal 1 minus alpha. Since there is not a single theta, so we need to divide it with 2 also with the both sides. Therefore, a 1 minus alpha 100% Ci for theta is summation I equal to 2 n minus 1 Si square over 2 chi-square alpha over 2 n minus 2 less than or equal theta less than or equal summation I equal to 2 n minus 1 Si square over 2 chi-square 1 minus alpha over 2 n minus 2.
Next, question 8D. For this part, we are given that the sum of square observation is summation of xi square equal 100 and the sample size is n equal to 15. Our task is to calculate a 95% confidence interval for theta. From the previous question, we know that the statistic involving the sum of square observations follow a chi-square distribution. Therefore, we use the chi-square confidence interval formula to estimate theta. The 95% confidence interval for theta is given by summation of xi square over 2 times with chi-square alpha over 2 degree of freedom n minus 2 less than equal theta and less than equal summation of si square over 2 times chi-square 1 minus alpha over 2 degree of freedom n minus 2. After that, we substitute the given values into the formula. The sum of square is 100 and since n is equal to 15, the degree of freedom n minus 2 is equal to 13. Then, we look at the chi-square table. Chi-square 0.025 13 is equal to 24.736, while chi-square 0.975 13 is equal to 5.009. We substitute these values into the confidence interval formula. Then, for the lower bound, 100 divided by 2 times with 24.736 is equal to 2.0213. For the upper bound, 100 divided by 2 times with 5.009 is equal to 9.9820. Therefore, we are 95% confident to conclude that the theta is in between 2.0213 and 9.9820. Alright, that's all from us. Thank you for watching.